Hello everyone, this is the last topic of this module, that is discrete distribution. And this discrete distribution means till now we have studied continuous distribution, and this is the discrete distribution. In this discrete distribution again we have three types, that is empirical discrete distribution, uniform discrete distribution and geometric discrete distribution. First we'll see the discrete uniform distribution. See, this is discrete uniform distribution. First we have to consider the PDF and the CDF. Okay, consider the discrete uniform distribution on from 1 to k numbers with probability mass function is given by, that is PMF, probability mass function is given by P of x is equals to 1 divided by k, where x is equals to 1 to k. Okay, so here as usual, the continuous distribution function CDF is given by f of x is equals to 0, if x less than 1, then 1 by k. In this range 2 by k, like that if I go till 1, k less than equal to x. Now we'll solve for this, the formula for this discrete uniform distribution. First you have to consider f of x is equals to r, and then we have to solve for x. Solve in terms of x in terms of r, that is r x is equals to f inverse of r, what we have seen. Okay, so here I'll just take r minus 1, r I minus 1 is equals to I minus 1 by k, less than r less than equal to r minus r I is equals to 1 divided by k. So we are just solving for x now, so I'll take r minus 1 less than equal to rk less than equal to I. So this one you'll get x is equals to ceiling function of rk. This is a ceiling function. Okay, this is the standard formula for discrete uniform distribution. We have solved the problem for continuous uniform distribution, that is different. Discrete uniform distribution is different. Now here also it is to generate the random variate. Generate 5 random variate using discrete uniform distribution. The random numbers are these random numbers, that is k means it is the total number of random numbers, so k is equals to 5. 1 2 3 4 5 random numbers are there, k is equals to 5. So how will you just find out? X1 is equals to rk. R means it is the first random number, r1 k. 0.57 into k is 5. So 2.85 you will get the ceiling function of 2.85. Ceiling function means you have to go for the next value, that is I am going to the next value, that is 3. In the same way x2, x3 you'll get 4, again x4 1, x5 is again the 4. These are 3, 4, 4, 1, 4 are the random variates for these given random numbers using discrete uniform distribution. And the last thing is your geometric distribution. And one more, your discrete distribution method is geometric distribution. So here first you have to consider the probability mass function over here. P of x is equals to p into 1 minus p whole power x, where x is 0 to n. Okay, so here the CDF is given by f of x is equals to summation j is equals to 0 to x, p of 1 minus p whole power j. This j varies from 0 to x. I'll just write it as f of x is equals to 1 minus p of x plus 1. We are solving for this for x now with the respect to this. So if you have solved this for x, we have to take the log on both the sides. So after that you will get it as x is equals to ln of 1 minus r divided by ln of 1 minus p minus 1. This is the standard formula. There is a need of geometric variate x that can assume values q plus 1, q plus 2. This is a geometric distribution, so we need a geometric variate. So in order to do that one, you have to just add q to this formula. So I'll just rewrite this with geometric variate q, that is x is equals to q plus ln of 1 minus r, ln of 1 minus p minus 1. Okay, in most of the cases q will be equal to 1. This is the standard formula for your geometric distribution, discrete distribution. So I'll come for the problem. Generate 3 values from a geometric distribution on the range x greater than or equal to 1 with mean 2. Okay, with mean 2 a geometric distribution has the probability mass function p of x is equals to p into 1 minus p whole power x minus 1, with mean 1 by p is equals to 2 or p is equals to 1 by 2 and q is equals to 1. P and q value it is already given, and r values r1, r2, r3, because you have to generate 3 values for geometric distribution, so 3 random numbers are given. Take this equation, x1 is equals to q plus ln of 1 minus r ln of 1 minus p minus 1. Q value it is given 1. Okay, so with mean is equals to 2 means 1 minus p, 1 divided by p is considered as a mean, but we have to solve for p, so p is equals to 1 by p. Ln of 1 minus r1 that is 0.932, r value ln of 1 minus p that is 1 minus 1 by 2. If you solve this one, minus 1, 1 plus this one, even here also you have to use a ceiling function. So I'll get the answer as x1 is equals to 4. So 1 plus 3.87, then 2.87 plus 1, 2.87 you have to convert into ceiling function, that is it is 3, 3 plus 1 is 4. So x1 is equals to 4. In the same way you have to just calculate x2. x2 you will get it as 2, then x3 again you will get x3 as 2. Okay, so 4, 2, 2 are the geometric variates what we have calculated from 3 random numbers. Okay, this completes your third module. Thank you.